Hello viewers, welcome back to my channel. This is Dr. DORCAS NGIGI, and today we're going to start with our third topic. Remember, we started with the first topic, floating and sinking. We went to our second topic, that is the thin lenses, and now we are in our third topic, and that is uniform circular motion. So I welcome you. Let's get started. So we are looking at uniform circular motion. Okay. So I know you know several types of motions. There's a motion we know already called the linear motion, whereby a body moves on a straight line. We also know projectile motion, where a body moves on more of a curve. And all these are different types of motion. So the one we'll be looking at in our topic is circular motion. And in circular motion, a body moves on a circular path. Okay? So in circular motion, a body moves on a circular path. Okay? So that is, if you have an object there, and it is moving on that, the path I've traced, then that body is moving in circular motion. We know many examples of circular motion from a merry-go-round, which people use a lot to have some fun, and it goes round and round. Okay. The other one is, for example, when you want to throw a stone and you first move the stone round before releasing the stone. That again is also circular motion. So those are different types of motions, and our circular motion, we have several examples. The two I've just given. Now, in circular motion, why does a body move on circular motion? We need to ask ourselves that. Now, to understand circular motion, we must first understand what we call force. Okay? Why force? Now, we know that force is that which brings a change in the state of a body. It is that property which brings a change to the state of a body. Why do I say that? Because we know from Newton's first law, we say a body should continue in its state. Okay? There are two states. A body could be in the state of rest, meaning a body is not going anywhere. So that body is in the state of rest. Now, or a body could be in a state of motion, meaning it is moving. Now, according to Newton's first law, a body should continue in that state. Whether it is state of rest or state of motion, it should continue in the same state. If it is in motion, it should continue in that state of motion on a straight line. Okay? And without any increase or decrease in speed, it should continue in motion on a straight line at the same speed forever. But we also say until when? So Newton's first law says a body should continue in its state of rest or motion on a straight line unless it is acted upon by some external force. Okay? So meaning, if this body is moving in that direction, okay? If a body is moving in that direction, number one, this body should continue in that direction. And it should continue at constant speed. Okay? Constant speed S. That is, if there is no force acting on that body. Okay? But what if there is a force acting on the body? If no force is acting on that body, it should continue on that straight line forever at constant speed. But if you come with a force, you apply a resultant force F on that body, then what happens is now we go to Newton's second law. This body here, let's say this body is of mass M. Now it will not move with constant speed. Remember, constant speed means zero acceleration, meaning the speed is not changing with the time, zero acceleration. If this body is acted upon by some resultant force, then we talk about this body moving forward, the same direction, because it is the direction of application of force, but this time it will move with changing speed. There will be delta S, changing speed, which we call acceleration when we divide that change of speed with time taken. And that is the basis of Newton's second law. Okay? That if we have a resultant force acting on an object of mass M, then that the speed of that body will change. If we are applying force in the direction of if we are applying force in the direction of where the body is going, then the speed of that body will increase. If we are applying force in the opposite direction, where the body is going forward, and you apply the force backwards, like when you are braking the car, the vehicle, for example, then we expect the speed to decrease, deceleration. Okay? Now that takes us to circular motion. This body should continue in what state? A body cannot go on a circular path if at all there's no resultant force acting on it. It should continue on a particular path, not a circular path. Okay? That is very important. Therefore, it means there is a force that is acting on the body. Force is what causes a body to change direction, to increase in speed, to decrease in speed, to stop, or a body that is stationary to start moving. That is called force. It brings change to the state of a body. Therefore, turning is just one of the effects of force. A body is moving in this direction with the speed, then it changes to move in a different direction. Even if it is going to move in another direction at the same speed, there is still some application of force, because the direction cannot change unless you have applied some force. Okay, too much on that. Now let's look at this circular motion. Now, to understand circular motion, one, we are talking about a circular path, so there is a center. And let's say the body started at this point. Let me call this point A. This distance from the center to any part of the circle, we know that is called a radius. Okay? Now, the other thing we know is that this radius, R, if the body changes from that point to this point, that's still a radius, but this body will have shifted from point A to point B. Okay? So the radius is the same. The radius is simply the distance from the center of the circle to where we have the circumference. Now this is point B. Now the body has moved from point A to point B. Now it is here from here. So it has covered that arc length. Let's call it S. The arc length, and by now we understand what is an arc length. It is a part of the circumference. So it has covered that point from A to B, and let's call it S. Okay? S is simply that displacement. And also remember, as it is moving from A to B, is also covering some angle there. Let's call that angle theta. Okay? So it is covering some distance in terms of something that can be measured in terms of length, meters, and it's also covering some distance which can be measured in terms of angles. Okay? Now, this displacement here, which is measured in terms of angles, we call it angular displacement. We call it angular displacement. Okay, so we are looking at a body that is covering some angle at the center, and it's also covering some distance. Okay, so we are looking at a case whereby this arc length here is subtending an angle at the center. So if we increase that distance to that point, let's say now our body is there at point C, now we have covered that distance. Now we have covered that distance, okay? We have covered that distance in terms of angle, so we have covered that angle. But in terms of the length, we have covered the distance from here to here, okay? So if we call this S1, then we can call that S2, okay? Now that is very important because it takes us to what we are calling the angular displacement. Now, I want us to go back to this circle. Let's say we have moved from point A to point, let me call it point D, and the arc length here is equal to R, is equal to the radius of the circle. Meaning, if you cut this part here and that part here, then you stretch on a ruler, then you will find that the length you get is equal to the radius of your circular path. The angle it will subtend at the center is called a radian. Okay? Let me go back. If you measure a distance from A to D, which is equal to S, so AD equals to S, and that AD, if you cut that length from here to here, then you stretch it on a ruler, then you find that the length of that S is equal to R. Okay? Then the angle you will subtend at the center is called a radian. So how do you define a radian? So we say a radian is an angle subtended at the center of a circular path by an arc length equal to the radius of the circular path. So a radian is an angle, okay? A radian is an angle. And it is not only just any angle. It is an angle that is subtended at the center of the circular path by an arc length equal to the radius. So when S equals to R, the angle we subtend at the center is known as a radian. That is very important, okay? Now the other thing we are going to look at is a whole circle has how many radians? Okay? A whole circle will have how many, a whole circumference will subtend how many radians? Because we are saying an arc length equal to the radius will subtend 1 radian. Will subtend 1 radian. So meaning the whole circumference will subtend how many radians? Now let's look. Circumference is equals to 2 pi r. Now, most of us don't understand 2 pi r. Let's understand 2 pi r. What does that mean? If you have a circle, then you cut it at that point, and this circle has a radius r. You cut it at that point, then you come and stretch it on a ruler. So that is your circular path. You stretch it on a ruler. The distance from here to here will be equal to 2 times pi, which is 22 over 7, times r. That's the length. From this point to that point, when you stretch the circular path on so that you get a straight path, in short, then the distance from here to here will be equal to 2 times pi times r, or 2 times 3.142 times r, because sometimes you give pi in terms of 3.142. So again, now you are getting an idea. So in short, circumference is 2 pi r. Okay? And we are saying 1 r subtends a radian. which we are calling radian. Okay? Now, the whole circumference, which is 2 pi r, will be equal to how many radians? So if 1 r is 1 radian, then 2 pi r, which is the whole circumference, will be equal to what? 2 pi r times 1 radian over 1 r. So it will be 2 pi radians. So don't get confused. I've just cross multiplying 2 pi radians times 1 radian over 1 r. Yeah? So it's 2 pi radians. This angle here, theta, is, we read it as radian. So a whole circumference has 2 pi radians. So if you move from point A all around back to point A, the angular distance, the angular length you have covered is 2 pi radians. So a circumference is 2 pi r. So 1 r, 1 radius, subtends an angle of 1 radian. Because we are saying when the arc length is equal to r, it subtends 1 radian at the center of the circle. So if you move a whole circumference 2 pi r, then you will have subtended 2 pi radians at the center of the circle. Okay? Now finally, let's look at what we are calling angular displacement. Angular displacement. So in angular displacement, we are looking at how many radians have we covered. Okay? What is the angular displacement? Angular displacement is angle, from the word angular, from the word angle. So we are looking at how many angles have we covered, how many radians have we covered. Now to know that, you need to measure the arc length from that point to that point. So let's say we want to, we have a circle, and then that's the center, and then I move from point A to point M, then now we have that. So the arc length is all that. So how many radians have I covered? Now to know that, I must measure the distance from here to here. What is the distance? You can take a thread, take it from this point to this point, then stretch it on a ruler. Take a thread, curve it the way the curve is going, then stretch it on a ruler. Then read the length. Okay? Now that is your S. Now once you have gotten your S, you know an S equal to the radius subtends a radian. Then how many radiuses are there on that S? So if I take S divided by R, then I'm going to get radians. And that will be my angular displacement. I'm going to get radians. What am I saying? S is the distance from here to here. That's my S. But an S equal to the radius is a radian. So this S here has subtends how many radians. Now to know that, because an S equal to the radius gives a radian, then I have to divide by R to know how many radians I have at the center. So this radians here, the S over R radians. Okay? It is the distance, that length S, divided by R radians. Okay? And that is what we call angular displacement. That is what we call angular displacement. So today we have looked at circular motion. We have looked at this, a body moving on a circular path. We have looked at several examples. Other motions, we have said there is linear motion, projectile motion. This is just one of the many motions that we have. The other thing we have said is when a body is moving on a circular motion, there are some forces that are acting on that body. There are some forces that are acting on that body, which we are going to look as we continue with our topic. The other thing we have said is there is an angle subtended at the center of the circle, and we call that angle a radian if it is subtended by an arc length equal to the radius. Okay? Now, therefore, we have defined that a radian as an angle subtended at the center of a circle by an arc length equal to the radius of the circle. Then we have looked at angular displacement. Okay, so what is angular displacement? We are looking at the length covered in terms of radians. And what did we say? If an s equal to the radius subtends 1 radian, then to know how many radians are subtended at the center, I simply take s, my arc length, I divided by the radius r to know how many radians. So the radians at the center is always given by that length s divided by the radius of the circle. And that you get s over r radians. And that s over r radians is your angular displacement. So in the next lesson, we shall look at what we call angular velocity. In our next lesson, we're going to look at what we call angular velocity. So I hope you enjoyed my lesson. Don't forget to like, subscribe, but most importantly, share this information with people whom you know require that knowledge. Until the next lesson, goodbye.